Most of what we think we know about zero is downstream of one or two sources, and those sources had reasons to oversimplify. Let's pull on that thread. Zero seems obvious. It sits between 1 and 1 on every number line you've ever drawn. You learned it before you learned to read. And yet, for most of recorded human history, zero didn't exist as a number. Not because people were enumerate. The Egyptians built the pyramids, the Romans built the aqueducts. Babylonian astronomers could predict eclipses. They had no zero, they didn't need one, or so they thought. The question isn't how zero was invented. It's why it took so long, where it actually happened. And why Europe, the civilization that eventually inherited it, spent the better part of 3 centuries trying to keep it out. Brigida the command of. Zero is now so embedded in how we think that it takes an effort to see it as an invention at all. Binary code is ones and zeros. Calculus turns on limits approaching zero. Every coordinate system has an origin, a point of 0, 0. Modern double. Entry bookkeeping requires writing down the difference between assets and debts, which sometimes lands at 0 or below it. All of that is recent, 3 or 4 centuries of use at most. What did people do without it? They managed, with increasing difficulty. The Romans had no zero and no positional notation. CMCIX is 1999, but multiplying it by anything requires converting first. Grieve. The Greeks had advanced geometry, but no place, value, arithmetic. The Pythagoreans could describe the ratio of a circle's circumference to its diameter, but had no tidy way to calculate with it numerically. The Egyptians ran sophisticated granary accounting and wrote out every denomination separately. Nothing didn't need a symbol because you simply left it out. The trouble came when leaving it out created ambiguity. In astronomical tables is a blank column a placeholder or a scribe's error. The Babylonians, sometime around the later centuries BCE, began using a 2 wedge marker inside numbers to indicate that a positional slot was empty, under the command of. Crucially, they never used it at the end of a number, and they never treated it as a quantity. It was 0 the parking space, not 0 the number you could add, subtract, or divide by. The command of. The standard account runs roughly like this. Greek mathematics gave the West its rational foundations. The Islamic world preserved and transmitted classical knowledge through the early medieval centuries. Europe then recovered that knowledge in the 12th century translations and built the Renaissance on it. 0 shows up somewhere in that story as an Arabic innovation, hence the phrase Arabic numerals. The Arabic world is given the credit. It's the wrong assignment, though the record isn't wrong, that Europe received 0 from the Islamic world. The Islamic world is a transmitter in this story, not the inventor. The deeper textbook assumption, that 0 is somehow downstream of Greek thought, is simply false. Greek mathematics was dominated by geometry, command of. Archimedes could compute precise approximations for pi using inscribed and circumscribed polygons. He did it without 0, without positional notation, and without algebra in any form we'd recognize, gung under the command of. The Greeks produced towering mathematical achievement inside a system that had no way to write nothing. That's not a criticism. It's a clue, under the command of. Zero required a philosophical commitment to treating the absence of something as a something. A thing you could work with, compute with, assign properties to. That idea was not Greek, it was Indian. The clearest early evidence for zero as a number, not a placeholder, but a quantity with arithmetic rules, comes from Sanskrit astronomical and mathematical texts. The most precisely dated is the Brahmagupta Siddhanta, century CE work by the mathematician and astronomer Brahmagupta. It states explicit rules. Zero added to a positive is positive, zero added to a negative is negative, zero added to zero is zero, and a positive or negative number multiplied by zero gives zero. Brahmagupta then attempts division by zero and arrives at problems he can't fully resolve. A sign that he was working at a frontier, not copying a finished system. Earlier Indian texts point to zero's development before Brahmagupta. A Sanskrit astronomical treatise, attributed to Aryabhata, composed around the end of the 5th century CE, command of, uses a positional number system with a placeholder slot. The precise form of zero in that text is debated by historians of mathematics, but positional notation with an empty slot is clearly there. The earliest surviving inscription of zero as a written symbol, a small circle, appears in stone at an Indian temple site, command of, with the inscription dated to the later centuries of the 1st millennium CE. The philosophical grounding matters here. Sanskrit has the word biplutu naya, meaning empty or void, a concept with deep roots in Buddhist and Hindu thought. The number zero didn't arrive from commerce or accountancy under the command of. It arrived because Indian intellectual culture had already established that nothingness is a real category, that emptiness is not the same as absence, not an error, not something you simply leave out. The number was downstream of the idea. Between 7th century India and medieval Europe stands Baghdad, specifically the House of Wisdom, the Abbasid era institution that, through roughly the 8th and 9th centuries, systematically translated Indian, Greek, and Persian scientific texts into Arabic and extended them. The figure most important for zero's westward journey is al-khwarizmi, a mathematician at the House of Wisdom in the early 9th century. His work on Indian arithmetic, the title of a Latin translation rendered as something like algorithmi de numero indorum, is where the word algorithm comes from. Khwarizmi didn't invent the Hindu numeral system or zero. His text credits Indian sources explicitly. What he did was present the full positional system, including zero, in a form that Islamic mathematicians could work with and extend. Over the following centuries, Arabic-speaking mathematicians did substantial original work in algebra, trigonometry, and optics, all of it using the Hindu, Arabic numeral system and its zero. Zero itself traces the rote. Arabic saif, meaning empty, derived from the Sanskrit baita naya, became zephyrum in medieval Latin, then zefiro in Italian, zero, and of. When you write the digit, you are spelling out the entire transmission chain in compressed phonetic form. Zero reached Europe through two main corridors. The first was the Iberian Peninsula. After the retaking of Toledo in the late 11th century, Latin, scholars gained access to Arabic libraries and translated scientific and mathematical texts into Latin over the following century. The second was Sicily, where rulers in the 12th and early 13th centuries maintained multilingual courts and sponsored translations of Arabic texts. By around 1200, several Latin texts describe the Hindu, Arabic system including zero. Europe then spent roughly 300 years resisting it. The resistance had two forms: the practical, the command of. Merchants and notaries working with Roman numerals and counting boards had no compelling reason to switch to an unfamiliar notation. The accounting worked. The second form was philosophical and, in at least some cases, legal. The scholastic tradition ran on Aristotle, and Aristotle had explicitly argued that a void, true emptiness, was physically and logically impossible. A number representing nothing sat uncomfortably with that. Command of. Accounts of Italian cities issuing restrictions on Hindu, Arabic numerals in commercial records circulate in the history of mathematics, based apparently on concerns that zeros and ones could be too easily manipulated to alter totals, though the surviving documentation for the scope of such restrictions is thin. Leonardo of Pisa, who traveled in the Islamic world as a young man and knew Arabic mathematics, Abaci in 1202 CE. The book laid out the Hindu, Arabic system with worked examples drawn from merchant problems, currency conversion, profit division, compound interest. The text circulated among educated readers and gradually influenced Italian commercial practice. The transition from abacists, those who computed on physical counting boards, to algorists, who computed on paper using Hindu, Arabic notation, played out unevenly over the next 2 centuries. By the 15th century, the algorists had won, but it had not been quick. Zero's story is often told as a clean westward march. India to Baghdad to Europe. The reality is messier, and the clean version hides some genuinely unresolved questions. What we don't know is substantial. The development of zero within India before Brahmagupta is poorly documented. Surviving texts are copies made centuries after the fact. Command of, and reconstructing the earlier stages requires inference from later sources. Command of. The exact chain from Indian mathematicians to the House of Wisdom scholars involves documents we don't have. We know the Arabic texts credit Indian sources, but the specific manuscripts and exchanges are mostly inferred. There is also the Mesoamerican problem. The Maya independently developed a sophisticated zero by around the 4th century CE, possibly earlier. Their zero had a distinct symbol, typically a shell glyph, and it functioned fully in their calendar arithmetic. It didn't transmit anywhere outside Mesoamerica. That means zero was invented at least twice, in entirely separate intellectual traditions, command of, which complicates any account that treats it as a uniquely fragile or unlikely idea. Of. Perhaps nothing is more natural than nothing once you're ready to think about it. Here's my read. The resistance to zero in medieval Europe wasn't stupidity. It was people in a particular metaphysical tradition encountering an idea that directly challenged it. Aristotle said a vacuum was impossible. If a vacuum is impossible, what is zero? The Indian tradition had spent centuries treating emptiness as philosophically real, betnaya, as a genuine category of existence, and that philosophical preparation made it easier to write a symbol for it and give it arithmetic rules. Europe had to work through a different inheritance. What's interesting isn't that Europe resisted, it's that the resistance eventually failed. Because the system that included 0 simply worked better. Not for every purpose, not immediately, but enough that the algorists eventually won. 0 is a story about what it costs to inherit a framework that doesn't have room for certain ideas, and what it takes to make room. Pull back. The textbook teaches you 0 is a number. Command of. It doesn't teach you that someone had to argue for that. That the argument took roughly 1,000 years, crossed 3 civilizations, and ran into metaphysics, commerce, and forgery law before it stuck. What survives is often what was useful to power, not what was true. 0 survived because it was useful. First to astronomers, then to merchants, then to everyone. A piece of this story changed your mind. Or didn't. That's the point. Until next time.